What I was told was that when it came time then to dispose of our competitors' machines, why would you pay so much money to actually ferry them back to Earth? So they got the 32 feet per second acceleration treatment, dumped them out, burned up on the way back to Earth.
As the story goes, they literally ejected your competitors' equipment to burn up in the atmosphere and shipped up some of your equipment.
That was the best part, yeah.
From EE Tech Media, this is Moore's Lobby, where engineers gather to talk all about circuits. I'm Daniel Bogdanoff. If I had a time machine, there are a lot of things I'd go do, but I know at some point I would head to Palo Alto circa 1939 and find a very specific little one-car garage. In this garage, two people are planting a seed that later grows into what we know as Silicon Valley. In here are Bill Hewlett and Dave Packard working on the legendary HP 200A audio oscillator, the piece of tech that started it all. Today in the lobby, we are joined by two people who have spent their careers at HP exploring and developing new technologies in HP's Advanced Compute and Solutions Group. Jim Nottingham, Senior VP and General Manager, and Bruce Blaho, HP Fellow and Chief Technologist. Jim, Bruce, thank you so much for being here. Can you introduce yourselves and tell us a little bit about the technology you work with at HP?
I'm Jim Nottingham, and I currently lead our Advanced Compute and Solutions business.
So this is the group at HP that does things like high-performance workstations and VR systems. Jim, how'd you get your start at HP?
So I started in 92. I worked at HP about 5 years, went with a few people at HP and did a startup that was very successful, and we sold it to Cypress Semiconductor. And I came back to HP 2001. I think I was gone for 3.5 years, almost 4 years. And I've been at HP since. I've worked most of my career, I worked in the printer business, the laser printer business, HP laserjets. Worked with a lot of great people and a lot of great leaders. Had the opportunity to live in Korea for a couple of years when we were integrating the Samsung printer business into HP. And at the end of that, I took the job leading the workstation business in our personal systems group. So I moved from print to PCs. And I've been here since. That was in 2019.
Bruce, how about you?
Yeah, so I'm Bruce Blaho. Again, also, thanks for having us on the program. So I've been with HP since 1985, so 36 years, and almost all of that has been within the workstation business or related businesses. My role, so I'm Jim's Chief Technologist.
I've always wondered, but kind of been too afraid to ask, what does a technologist do?
My role is to try to get the new stuff going, so find new business opportunities. So that includes, understanding the technology trends, but also, I think often more important, the customer trends, the industry trends. What's been interesting for me is in the business, I've been here long enough, the customers are the consistent thing. They're still trying to get the same things done that they were trying to get done 30 years ago, but the technology and tools we have change over time. So it's been really interesting for me to see the evolution and how we can help these folks get their work done. One of the reasons I've stayed, I'm doing what you're not supposed to do, staying in the same business for a long time. The reason I have is it's a couple reasons. One, HP is just a great company. I got very lucky. I've had the chance to have many careers, if you will. My roles have changed pretty dramatically from when I started to now, so it's always been interesting. In fact, working for Jim these last, 2.5, 3 years, I think I've never been more challenged and had more fun. So as long as it keeps being fun and challenging, why would I go someplace else? Our customers are so interesting too. The engineers and scientists and movie makers and creative folks that we sell to and that we work with and with whom we collaborate are really interesting. Some of the sharpest people on the planet. So that's when Jim told me about this podcast. I was real excited to get a chance to talk with you and share maybe a little bit of what HP is about with your listeners, as this is a really interesting group.
Yeah, I when I came out of school, I didn't realize the breadth and depth of in the history of HP and what Hewlett-Packard has meant to the tech industry over the years. Can you give us a walk-through time of how HP has left its mark on the tech industry as a whole?
So HP was founded in 1938, and it's actually considered the garage in which Bill and Dave, Bill Hewlett and Dave Packard started the business. Is actually a historic landmark now. It's considered the birthplace of Silicon Valley. So HP is really the original Silicon Valley startup, if you will. Bill and Dave were both double E students at Stanford. Their advisor and professor encouraged them to start their own business, so they did, and they started it in the house that Dave Packard and his wife Lucille were renting, on Addison Avenue in Palo Alto. The garage out back, a single car detached garage, was their workshop, and that's where they built their first products. First product they brought to market, the 200A. They named it. It's kind of like when you get a new set of checks. Back when we did a lot of writing checks, right? You start the numbering. They took 200A, so it would sound like we've been doing this a long time. You don't want it to be product number one. It's right. The 200A, and they actually sold several of those to Walt Disney. So it was their first big customer. Walt Disney used their audio oscillators. They used them for the movie Fantasia. Some of the other landmarks along the way. HP invented the first scientific calculator, and the financial calculator. The 35C is still sort of a cult favorite today.
I still use it.
Still got yours? Yeah, I know a lot of people.
I still use my 41CX too.
Okay. Yeah. Yeah. So that was some of the claim to fame. Obviously, then one of the other big hallmarks for HP was the print business. I'm going to let Jim talk about that.
Yeah, I think on the print side, first, HP kind of invented the inkjet technology with, somebody that was kind of noticing their coffee pot, how the coffee pot drip was working, and they had some big ideas, and it's evolved over time and really, perfected and evolved over time to really enable very high resolution, very high quality inkjet prints. But that technology has also been used for what we do with 3D, 3D printing with multi-jet fusion. It's enabled us to do a lot of what we're doing in the microfluidics and some of the healthcare space. The technology is used pretty broadly in HP. Along the way, we were also doing some work with laser printers, working a little bit with Canon. They'd come out with this new, an optimized laser printer where HP partnered with them, and HP did the controller, and HP created the printer command language at the time, PCL, which was a big deal.
PCL rings a bell for me. What does it do?
It enabled software writers to create, apps that could easily print and create images on these laser printers. And so HP and Canon formed a relationship that's going on, 35 years. This partnership where HP has done a lot on the controller side, the imaging, the processing, the PCL, and Canon has continued to perfect and evolve the laser printing. It rolled into color laser printing, and then obviously the supplies. Pretty interesting how much research and development goes into supplies in terms of making them sustainable, reliable, high quality. There's a lot of work that goes into the supplies. So we've partnered with Canon on the laser side, and HP created the laserjet product line. That laserjet's one of the most recognized brands in the world, and it's been a great business.
In the space of 15 seconds, what's new in the printer business for HP?
2017, we acquired Samsung's printer business, partnered with Canon, but we also have the Samsung technology that we use for copiers. HP also kind of made a pivot from just selling printers to managing printing. Lots of innovation on the print side and on the personal system side.
We'll be right back to talk about what some would call the good old days of HP hardware and the good new days of HP hardware. Moore's Lobby is sponsored by Future Electronics. As medical cases worldwide have soared, so too has the demand to design smart, connected, and secure IoT-enabled medical devices. Microchip and Melexis have joined forces to create a development kit that helps medical clients meet those challenges. Combining Microchip's CPU, power, Bluetooth connectivity, and security with Melexis' contactless temperature sensors, they can offer customers a complete telehealth vitals monitor reference kit. For more information on this reference design, visit futureelectronics.com. And now back to our interview with Jim Nottingham and Bruce Blaho from HP. I have a couple questions from like a engineer hardware perspective. What makes a laserjet printer special and unique? What about the technology inside of it? And can you give us just an overview from a technical standpoint of how a printer thinks and works?
We could probably turn this into like a 3-day podcast on that question. But just at a high level, the it's really the optics, the technology inside of the printer in terms of how do you get the speed, how do you get the quality. It's all a function of they call it a laser printer. It's not the jet. There's actually a funny story about that. When they first named it laserjet, some of the engineers kind of tried to protest. And they had a big sign on the building when the VP came to visit that said, "Where's the jet?" But the horse was out of the barn. They'd already named it, so that was a short discussion, and the rest is history. But it's basically, it's a laser that changes the charge on the paper. You put a charge on the paper, the laser changes the charge, then the toner sticks. The toner sticks to the charge or lack of charge, depending, and then that toner on that paper goes through a fusing process where it essentially heats it up and essentially melts it to the paper. That technology to first get the resolution. There's a tremendous amount of innovation on the supplies down at the micro level to really get the supplies in terms of how you structure the supplies, both to be high quality, all the things that customers like to see in terms of what it looks like on the page, but also in terms of the quality, the reliability, and the sustainability, and the environmental. There's just a ton of research that goes into that, and Canon has over the years just really perfected, and they've got their way of doing it. Everybody's kind of got their way of doing laser printing. It really boils down to there's just a tremendous amount of IP on that laser side. Now on the controller side, there's a lot of intelligence that goes into, how do I render the image, and how do I process the PCL or the PostScript, and how do I actually translate that into the map that's going to put the right dots on the page to make it look good. And of course, when you get into color, there's a tremendous amount of color science involved, and compression and data compression. There's lots of technologies involved when you start talking about super high resolution, high color, photos. They at least back in the day, they were pretty big file sizes, and so there's lots of compression, there's lots of color science, there's half toning, there's a tremendous amount of things you can do in the product, and then there's lots of tricks you can play with the electronics to make the print quality look better. And you'd be surprised at how much performance it takes to print. If you want to print full color pages at 60 pages per minute and have them look super high quality like photos, there's a lot of work, technology that goes into that in terms of processing, how you compute the firmware, the software stack that is on top of it. HP's done a great job to continue to innovate and create new value.
What I'm hearing is that there might be a jet in there somewhere, but it's hidden in the IP and you can't talk about it.
On the inkjet side, it's true, because there is a little jet, there is a little stream of ink.
You don't jet the toner out?
Bruce, you mentioned you started in 1985. That's kind of at the budding brink of when personal computing was really ramping up and becoming a viable technology for consumers and businesses. With HP being a engineering test and measurement company, the test gear behind me is all Keysight Agilent HP. How was the printer and computer business received internally, and was there any internal struggle to get that business off the ground?
Well, the compute business was kind of a natural offshoot from instruments. As a matter of fact, I remember the first HP computer I used. I was a summer intern at Kodak back in Rochester, New York, and HP had a very instrument-driven computer. It was actually one of the first all-in-ones. Had a little display and had all sorts of instrument inputs. And what we used it for was for controlling machines. My project was to do an automated film testing machine. So it powered little stepper motors to advance film samples through and rotate camera lenses to take pictures and then gather the data. And so that was a very test and measurement kind of application. And so I think that we kind of first got started in the computers because we needed them to do, as a natural tool that we needed to do our testing and measurement business. And eventually, of course, that grew into a full mini computer business and went off from there. HP has always been fairly, Bill and Dave had a philosophy and built a culture of self-sufficiency and independence. And so, the compute business and the test and measurement business were run fairly separately. And so, the folks working in computers were into computers, and the folks working on tests were into tests. So I don't think there was a lot of, I think all of us welcomed the growth of the company. So I don't think there was anything like that, any negativity or anything towards it. Always, though, I think there's, over the years, there are cultural differences. Jim and I joke about we're both double E's, and double E's have a way of doing things and a way of thinking about things. As we did more and more computer work and operating systems and compilers, you hire a lot of computer science people. They have maybe a little bit different way of thinking about things. So sometimes there's a little bit of good-natured ribbing and it goes back and forth, but I don't think anybody, there's no resentment or anything like that.
I think it's an interesting question. Because at HP, really from the inception of the company, Bill and Dave, the values that they built, it was really all around creating, innovating, creating new value for customers. The whole printing thing, when the laser printer became, small and affordable, and HP made it easy, the people could just use a laser printer. I remember, writing my thesis on my master's degree in EE, and I was one of the first ones that used a word processor and a laser printer, and even the the lady in the office that you had to turn your paper into, she was a little bit perturbed that it was easy. It was so easy. It was kind of like a rite of passage on your thesis had to be, the typesetting and the measuring, and it was just like I just did it all in.
Yeah, you lucky dog. Yeah, my thesis was done with whiteout and hand and rulers, and X-Acto knives. Yes.
I kind of rode that transition where typewriters went from. Typewriters were everywhere, and typewriters went from being everywhere to being nowhere, like really quick. And I rode that transition. But HP, there's never really resentment. Obviously, any business has got to prioritize. And at HP, there's so many things we could go do. We can do anything. We really can, but we can't do everything. And so, there is prioritization. And a lot of times when you go through prioritization, people want their toy or their cool thing to be prioritized. But for the most part, HP has thrived, really around its values for developing employees, giving them taking smart people, giving them the ability to learn, engaging them with customers, and turning them loose on finding new and better ways of doing things. And that has turned into a lot of big, good businesses over the years.
Big part of what they call the HP way.
That was my next question. Is that still alive and kicking?
Yeah, absolutely. There's been books written about it. Bill and Dave wrote a book about it. To me, the HP way is very real, and it's really just a fabric of values that the company is built on. And I honestly see it. It's not like the HP way is not like some management speak. It's really, in my view, it's a timeless business model that really enables companies to be successful. And I've seen it. I've had the opportunity to work with other companies, integrating them into our company, and there's always huge cultural differences. And a big part of the HP culture is really the fabric of the HP way.
For me, starting at Agilent and Keysight, when I interviewed, you could just feel the energy and the passion of the people in the room, and I think that is something carried over from HP for sure. So I agree that it's less about a specific set of tactics, and it's more about a mindset and a philosophy of how we approach technology and development overall.
Yeah, and the opportunities that it enables. I can tell you, coming out of school, I had no clue. I wanted to be an engineer and do cool things, but I never had any idea, kind of what I would end up doing. I never thought I would be doing what I'm doing today, but it just came from the opportunities that HP presents when you get the opportunity to work with customers and lots of extremely bright people and leaders who have literally forged and changed industries. I've walked with giants, and I can say that with a with a very straight face. I've walked with giants, people that have created categories or created segments and industries. It's pretty cool, and as long as you're intellectually curious, ambitious, and you want to, you have the ability to figure out what you like to do. There's just so many opportunities at HP.
I mentioned earlier, within the workstation business, we're working with a lot of creative folks, engineers, scientists, movie makers as well, and so we have the Z workstation lineup that we have includes a display lineup as well. There's Z displays that HP sells, and these are the professional level displays, and that's where we focus, and that's what we've worked on. So displays for professionals. So that includes, in particular, photographers, movie makers, folks that care about color accuracy and care about color consistency. So that's sort of the big difference between, what's the difference between a professional display and a normal display. You want the colors to be real, not necessarily just popping and pleasing. You don't want cartoon colors, you want accurate colors. So if you shoot a movie, what it looks like when you saw it live, what it looks like in the camera, what it looks like on the display needs to be accurate and real, and it needs to be consistent. So for instance, one of our early partners in driving professional color was DreamWorks animation. So you may have hundreds or thousands of folks working on a movie, from the artists to the animators to the folks that are doing the editing at the back end, or 3D processing on it. The green color of Shrek needs to look the same, on every day, from day to day and from every machine. So all of those 100 folks, if the colors are different on each machine, then it's going to be a mess. The movie's going to be a mess. And so that was sort of the focus for the work that we did.
And it was award-winning work, I might say. You've won some awards that people might know.
He's a little humble there, Bruce.
Yeah, I was just going to get to that. So one of the real highlights of the display journey was working with DreamWorks Animation. They made us aware of a crisis that was happening in the industry as the industry moved, and we all moved from CRTs, you remember those, right? The big boxes, to LCDs. LCDs were great. They're thin, they're inexpensive. Everybody loves flat screens. But the big problem was the color was rather terrible, especially in the early days of that. And so for the movie makers and TV producers, they ended up having to stockpile very high quality Sony CRTs that had the color accuracy and the ability to be calibrated and the consistency that I was talking about. The LCDs had very poor quality in a number of issues, and so we collaborated with DreamWorks Animation to define what we ended up calling the Dreamcolor monitor line. And this was the first in the industry, the first LCDs that had low black levels. If you've ever looked at an LCD in a darkened room, it's really kind of bright gray. It's very bright. Getting good black levels, getting accurate color, getting consistent color, the ability to calibrate the display, and put it to and assign it to different color spaces. Each movie, you may not realize, each movie usually has its own set of color spaces and color palette that it's going to use. And so it may be that if if today I'm working on movie A, I need my monitor set up, in this way. Tomorrow or next week I'm working on movie B, I need to set it up differently. So being able to store all those settings, being able to have those professional features, was a real breakthrough. And then I think it was 2015, then HP actually won our first engineering Oscar Academy Award for that work. So that was pretty exciting. We don't get a lot of Oscars.
Yeah, it was pretty cool. On the print side, we actually worked a lot with the teams developing the Dream Color display, because on the print side, consistency is a huge thing especially when it comes to color. We spent a tremendous amount of time with Canon and others on our ink side internally, and with Canon, on the toner side, and on the print engine side. Basically, you have a couple of vectors or dimensions of consistency. So first, if I sell a customer 1,000 laser printers, color laser printers, number one and number 1,000, we want them to look the same. When they print, they've got to be the same. As if they're printing their company's light blue logo, it's got to be the right light blue every time. And so that's one vector of consistency, or one axis. The other axis is on the device. It's got to look the same on page 1 versus page 10,000, over time. And so there's a tremendous amount of work on the color science side and consistency side in terms of how you calibrate. And then, of course, people want what, on their printouts, they want their printouts to look like what they see on the screen. And so the consistency between the display and the paper, it sounds kind of trivial to talk about it, but there's actually a lot of science. There's a lot of engineering behind that, where we had to do a lot of work and align on different color standards, and how you go from RGB to CMY and K and make those look the same. It's kind of an interesting problem to go solve.
That was one of my first big collaborations with print. Is like Jim said, you want it all the way through, from what you see on the screen to what's getting to the posters that are being printed. It all needs to look the same.
Coming out of engineering school, I don't think Bruce ever thought he was going to be winning an Oscar award.
I know, definitely not.
and we can talk about it maybe later, but just for the record, Bruce has been involved in winning an Oscar and an Emmy. Last year, we won an engineering Emmy.
So what is the plan for the full EGOT? You just need a stage performance and a Grammy, and you're good to go.
Yeah.
I could, maybe the Grammy. We've done some work on audio, but don't hold your breath on the Tony. Although our workstations are used for live productions. Lady Gaga and some other folks have used our systems to run their stage show and that. But it's probably a little bit of a stretch. Yeah, for the Tony.
You can't just leave that Lady Gaga thing hanging. Can you tell me a little more?
Our Lady Gaga concert, our general manager at the time, she was playing in Denver. He went down to visit and went to the show and went backstage and brought back pictures of all of the, high-end workstations. Yeah, the workstations. Yeah, that she was using. So they do show up everywhere.
This episode of Moore's Lobby is sponsored by We Talk IoT, the smart industry podcast. Keep yourself up to date on the most important developments in the world of IoT, IIoT, artificial intelligence, and cognitive computing. Listen to leading industry experts, business professionals, and experienced journalists as they discuss some of today's hottest tech tips and how they can help boost your bottom line. Join us at We Talk IoT, a regular series of podcasts from the editors of Smart Industry, the IoT business magazine. Listen for free now. And now back to Jim and Bruce from HP. Going back to the color accuracy thing, I would say, as someone who has done some video editing and color correction, there's nothing more infuriating than moving a project from one display to another and watching the color change and then exporting it and looking at it on my phone and seeing, like, why is my face so red or the background so dark? It has just been a mess. So the technology is really plays a critical role, I'm sure, in pro grade productions.
It's a very challenging engineering problem. Yeah, definitely. As Jim said, the the colors that are available in each display and each printer are quite different, right? The palette that's available, and so trying to recreate the same range of colors, yeah, is sometimes, some of the colors, that I can put on the display, I can't print, vice versa. They don't exist. Yeah. So especially if you go to, then, like, say, a phone that has other goals, like being, thin and light, and maybe if it's a lower cost phone, yeah, it's, yeah, quite sometimes it's not possible to be this exactly right.
What about the hardware of a high-end display is better than, say, a phone display or a $100 monitor? Is it higher quality pixels, higher, like, power supplies? What makes it tick?
Yeah, there's a lot of things. There's a lot of things that go into it. The panel itself can make it quite a difference. Although that's gotten a lot better, as happens in technology over the years, things have gotten more consistently good. High end, it used to be IPS. If you've heard of that, IPS panels were unique to the professional space. Now that's kind of come down over time. That even consumer level displays can so the quality of the panel matters. The backlight makes quite a bit of difference, right? If it's an LCD panel, if you're familiar with how that works, right? The LCDs are little light valves that open and close. You have to have, and filter for color. You have to have a backlight, and so, the difference between having, say, just the older displays just had a fluorescent tube back there. Newer ones have LCDs. How many do you have? What's the quality of those LCDs? Nowadays, with HDR displays, we can actually do things like dynamically modulate the brightness. If you want to get more contrast, to do things like HDR, you can dynamically modulate the backlight. I find that an extremely fascinating technology. If you think about it, then you've got to, on the fly, 60 times a second, if you will. If I brighten or dim the backlight, when I've got to change the value of the pixels, right? If I brighten the backlight, if I want to maintain the same color, well, then I've got to dim down what's coming through the pixels. And so this is a very real time, very dynamic um, uh, engineering problem. And then if you think about that, and then you've got the electronics to control it, right? So who's controlling all of that? So that's very akin, I imagine, to what Jim can correct me if I'm wrong. I imagine that's similar to what's going on in the printers as well.
Yeah, at a high level, your question is really difficult to answer, but at a high level, what's best is that, beauty is in the eye of the beholder every time. And so what's best really starts with the use case and what's the customer going to do, because it's all about, at the end of the day, it's really the fundamental things and the physics of your eyes. Contrast, color, color, color depth, or the vividness of the color, the blackness of the black, darkness of the blacks, the lightness of the whites, how you control that gradient, the refresh rate, of the display is a big deal. So I can have a display here that looks, much better than a display on a PC or a standalone monitor, just depending upon the technology. But it all boils down to resolution and all the things that matter for the application or use case that you're doing. Because watching, streaming a video is going to have different parameters of quality than looking at, very high resolution synthetic graphics, for example.
And there's some elements of personal preference. Some people love a glossy display. A lot of our customers hate that, right? If you're doing work, a lot of people like a nice glossy, glass surface. Other people want matte. I don't want any glare. And we'll have a product, and I'll have customers walk up in either camp and say that's great or that's so terrible. because I like it this way.
Have you done touchscreens at all? Because that becomes a whole deep dive topic of.
Oh yes.
That gets to be even more tricky. Yeah, for sure.
Yeah, I spent probably about 15 years on touchscreens and pens, trying to do a display based pen. Yeah, that gets very complicated. How do you, the stack that you have to build to do that and yet maintain good visual quality. Lots of trade-offs there.
As we talk about quality, it feels like workstations is a topic that we should get to, because the processing side of all of this is very important as well. So my first question is, how do you define a workstation? What makes one thing a workstation and one system not a workstation?
Great question. There's actually, definitions out there with industry kind of standards or industry groups like IDC, and they've got criteria around workstations. So there's certain requirements on the CPU. There's certain requirements like ECC. You've got to have error correction, coding support. You've got to there's certifications that you can get on many of the software applications to let you know, hey, yeah, this has been certified to run this. And again, it's all around reliability and consistency. There's also criteria around what kind of graphics processing you do, or what kind of additional processing you do with the GPU. And within that, now they've, even within workstations, they've kind of got different tiers of workstations, but those are the fundamentals.
The way I think about it is more the customer and the usage. It's the professional, it's professional compute, highest performance compute. Things like we talked about, the professional displays. These are driven by the requirements of engineers, scientists, creators.
Yeah, I gave you the industry kind of response. I mean, from our view, the workstations are really just a special class of commercial products, enterprise commercial products. And Bruce is exactly right. The thing that really defines the workstation is the user, and the customers that need workstation capabilities are typically the customers that are using very computationally complex tools, and they have very complicated workflows to do the work that they're doing. So they require, extremely high reliability. They require high security. They don't want to lose their IP. They don't want to get through a 2-week, run of crunching numbers for 2 weeks only to have the machine go down and you lose your data, or every other day. You got to have reliability. You got to have the security. You got to have the performance. And there's just a never-ending thirst for more performance. And during the pandemic, that accelerated because of the entertainment, the content creation, the number of freelancers, that are now working from home. The jobs to be done are just evolving, and so more and more customers are needing the capabilities that workstations provide because they want to do more faster. And that that industry, that drive for creation, or in the case of like the data wranglers, the data scientists, the ability to find those golden nuggets in massive data sets. It just requires more and more compute. The reliability, security will always be there, but more compute. And then our customers need more than specs. We can come out and say, yeah, it runs this fast, we're the highest power, we're the most performance. But at the end of the day, it's all about their workflow. And does that performance really help me do my job better? Does it make me more successful? Does it make me more productive? And when you say, hey, I've got higher performance, does that make my day, 15 seconds shorter? Or does it make my day, 3 hours shorter? So it can be a big deal. When you get the right compute for the use case, it can literally save, our customers a tremendous amount of time, days out of a week, Or stated another way, it allows them to do more iterations on either their creation or more iterations to find those golden nuggets in their data. So it's kind of a really big deal that high performance compute for these use cases, these customers, is really what defines a workstation.
And Jim said a couple of things that were really important that distinguish workstations from other high performance machines. I have a lot of people will say, well, why wouldn't I use a gaming machine, or so and so overclocks? How about if we do that? And one of the big differences, a couple big differences for workstations, Jim talked about the reliability, right? I've had a lot of folks that work over the years in HP's gaming business will say, oh, well, my machine's faster than yours. It's like, yeah, but mine needs to run mine needs to not crash, right? When you overclock, we had a customer that was evaluating an overclocked machine because they said, hey, we just need another 20%, and the overclocking gets us there. And it looked great when they benchmarked it. And when they put it out into their first department to do real work, this was a movie maker, studio company, the first week, the machines would blue screen 3 times a day when they put them under load. And that gets to the other big difference between a workstation and, say, a gaming machine or other high performance machines is the workload. A lot of people say, oh, you build sports cars. And it's like, no, I don't really think of the workstation as sports cars. This is like a pickup truck or a semi tractor trailer. It's the workload. We are high performance under extreme loads, huge, as Jim said. The data scientists are doing queries into multi-billion row data sets. These folks are doing video editing on hundreds of files or hundreds of gigabytes or even terabyte sized workloads. And so that's the other really big difference between just buying a really specced out, because if you just look at the specs, it's like, well, I've got an i7 and some RAM and it looks pretty good. But there's a big difference when you try to do these industrial sized workloads at speed. That's a workstation.
So, what makes a workstation bigger than the sum of its parts? Because obviously, you're pulling in, like we had the CTO of NVIDIA on a recent episode of this podcast talking a little bit about GPUs and graphics cards. You're pulling in, like you mentioned, i7 and Intel processor. So this is a conglomeration of many different vendors' parts. What makes that better than the sum of its parts?
Yeah, that's a great question. And NVIDIA, Intel, they're all very important partners of ours. As AMD as well. So the thing that makes it better than the sum of the parts is really it gets down to the customer and the workflow, because how you optimize that workflow, how you take advantage of that performance to make the workflow better for the customer, that's where there's a difference. That's why when I say our customers need more than specs, it really boils down to how are they using it and what's the experience you build around those specs and you use those specs to enable that really matters. And so there are things that differentiate us from other vendors. It starts with even just the ability to do the thermal design. When you start packing this kind of silicon and this kind of performance into a little box or into a notebook, you got a mobile workstation, it's no joke. It's no trivial problem. The thermals that you're talking about, there's a tremendous amount of power that comes off of these products. So both in terms of managing the power to reduce, to be more sustainable, there's work to be done there, and the ability to throttle the performance or to cool, keep the cooling up with the performance to ensure that the system doesn't get too hot. If it's a notebook on your lap, you don't want it to burn your lap. If it's a desktop that's loaded up with a lot of GPUs and CPUs and a lot of power, you don't want that thing to be super noisy because the fans sound like a jetliner under your desk.
Yeah, we don't want a jet.
Yeah, we found it.
Yeah, to have a kilowatt power supply in these things and yet be quiet to run in an office environment, yeah, that's a huge task.
So that's some of the engineering behind it, is the thermodynamics. Then there's optimizations around the performance. How do you work with the ISVs to really optimize that performance? and configure or architect your system to take advantage of the pieces parts you have so that the workflow benefits the most from those pieces parts. There's the acoustics and the audio engineering. Now with more conferencing collaboration, it's all about the cameras and the microphones, the audio. We have a lot of creators that use our workstation products because they're doing these these kind of game changing things that are very complex, but they want good audio, they want good cameras. And even if they're not collaborating conferencing, they want good audio because a lot of the creators, they get in a zone and they're going to listen to music, or they got their headsets on. They want the whole ecosystem to work well and enable them to really get in their creative zone and do the things that they do.
If we go from one central beast of a computing workstation into edge-based computing, how does the edge and how does this core central computing, how do they play together?
Now, I'll give you the high level answer. We'll let Bruce, give you more details. But I mean, this is edge computing.
Your phone, yeah.
My laptop is an edge device because it's at the user, and then you've got the cloud, which is in some data center somewhere, and that's distributed computing. And there's tremendous benefits of the cloud. I mean, for sure, and there's a reason why the cloud is here forever and will grow, continue to grow. Having said that, between this and this data center cloud that's somewhere, there's a lot of room for optimization, if you will. This whole client server model, the pendulum has swung back for 30, 40 years on client server. And I think the optimal mix really is it boils down to, again, the workflow and the experience for the customer. There are some experiences that you can only light up at your fingertips.
So you have to have some of both?
You hear people talk about hybrid. There is a need for things that look like the cloud, but the data is local. You take the compute to the data rather than taking, the data to the compute. And in those cases, you'll hear terms like bare metal cloud or edge, edge platform that basically give you local capabilities that look and feel like the cloud, but they're more local or near local because of the constraints in terms of moving or manipulating or working on that kind of data with the kind of cycles and performance that you need.
Bruce, is there anything specific about a workstation that makes them particularly suited for doing like AI on edge applications?
Yeah, no, definitely. And frankly, that's how I kind of got into edge computing, was started with AI and data science. I mentioned before how large a data sets our customer use. So I've spent a lot of time looking at the trends. The growth of data is and has been exponential. Or the growth of, like, say, bandwidth to move it is not. There's a huge gap between the amount of data created every year and our ability to move it. And so when we looked at that, we said, wow, there's a huge amount of data, like 80% of it, that's never going to make it to the cloud. Okay, but what do you do with it? And it's like, well, that's where AI and data science come in. How do I take all that data and get some insights and actionable insights from that? And that's where edge computing, I think, really gets interesting and allows us to build new solutions, new site-based and on-prem solutions that really weren't possible before. And so things like, frictionless checkout store, like an Amazon Go store. Amazon's a cloud company, but I'm telling you, all that compute is at the edge. There's no time to move 100 cameras worth of data to the cloud and think about it and then send back an answer. I need answers. So the bandwidth, the latency, often the privacy of the data all says I've got to do that heavy lifting. So you need a powerful machine. So that's where workstations come in. Having said that, if you think about where you're going to run these solutions, in factories, in grocery stores, in hospitals, these are not data centers. I don't have a professional IT staff. I don't have an air-conditioned, climate-controlled room. It's going to be messy. It's going to be back rooms, maybe a closet, that's where workstations shine, right? They're more rugged than servers. They're quieter. They're flexible. I can put them any place I want, but I can still load them up with multiple cores, multiple GPUs, loads of RAM. If you think about, like, say, the example of the frictionless checkout system in a grocery store, right, where I've got cameras all using computer vision to notice that when what you put in your shopping cart or what you put in your bag, to identify that on the fly, to keep track of what you've got, what you've purchased so far, at least what you've picked up so far, and then ring you up automatically when you leave. There's a tremendous amount of compute, and yet again, I don't have on-site IT, I don't have a data center, so it needs to be a quiet, powerful machine that fits the workstation design to a T.
What Bruce is saying really is it really boils down to the use case, because workstations are not all things to all people. The servers, data centers, they do an amazing amount of things that workstations are not the best solution for, just like a PC is not the best solution for everything. And having a distributed kind of compute is a better answer in some use cases, even at the edge. You can have a data center looking edge, on-prem solution for some, some use cases that are similar to what we're talking about, where they've got a need to have the data local and it can't be in the cloud. A data center server on-prem or near-prem is the right answer. But in the cases that Bruce is talking about, and there's a growing number of these cases, where this one-on-one compute, where you really need dedicated compute for a certain task, and that's where AI, a lot of these AI and machine learning applications come into play, is you can run these things, you got a tremendous amount of flexibility for the use case, where you get better cost performance than if you ran it on a shared compute.
So it can't be all shared or all local.
Our goal in life is not to be, workstations are going to replace, dominate the world. They're going to replace everything. It's like workstations are going to fill part of this spectrum of compute. Workstations provide a very important capability in this spectrum of compute that gives customers a price performance advantage in many use cases. And so, some of the things that Bruce was talking about, like frictionless retail or visual inspection, any computer vision applications, it's almost like disposable data. It's like you're capturing a tremendous amount of data that you're running very computationally complex algorithms on to make decisions, and you want those decisions in real time. And as soon as you've seen the data, processed, made the decision, you throw it away. For the most part, there are just a tremendous number of use cases where you need, the latency, the performance, the cost, the locality. You need local compute. You need to compute at the data. Before people were talking about the edge, there were edge use cases. You have people out on an oil field, or out in the middle of nowhere doing spatial geo work, trying to identify where there's oil or some other geological information. And they were working with tons of data. They're not connected to anything. It's not going to any cloud. It's not going anywhere. They had to do the processing at the edge, literally. And so, that's one of the oldest use cases around for the use of workstations.
I want to ask about a couple use cases, one of them being maybe the most extreme case of edge computing today, the International Space Station. I hear there's some HP gear up there.
I'm going to bubble it up just a little bit, because it's really what inspires me about this job. I mean, like, this is my dream job. And when I took this job, I knew it was exciting, but I didn't know it was my dream job. We work with the world's most creative change makers. We just do that, because typically with people that are out there pushing the edge and changing the boundaries of what is possible and what is not possible, those typically involve a lot of computation, a lot of trials, a lot of iterations, all the things that kind of work their way back to the need for this really high performance compute that we provide. And so we equip the world's change makers to go out and do their thing. and they trust us. They trust our brand. And I'm telling you, it is the coolest thing ever to be working one day with someone at DreamWorks that's making dreams for kids, and the next day be working with someone at SpaceX that is, figuring out how to make space possible, space travel, bring it to the masses, or working with NASA and all the things they want to do with the space station and all the exploration that they're doing, or the people that are solving for the vaccine, or helping people get well with the diagnostic. I mean, the list just goes on and on and on and on with the customers that we work with.
Bruce?
Yeah, I think from an engineering point of view, NASA's been a long-time customer of ours, but they did have somebody else's machines, computers on the space station originally. They became dissatisfied with them. They came to HP and said, "Hey, we've worked with you for years. We love your stuff. But let's talk about security. Let's talk about reliability. Let's talk about servicing." Those are all things that become extremely important when you're on the space station. And so there were definitely a few extra laps that we had to run to get things right for NASA. But working with them was great, as Jim said. I had a chance to go down to Houston a couple times for symposium conferences that they're doing there. They've really become very active in recent years, pulling together industry leaders and tried to become not just a consumer of technology, but a leader of technology. So it's great to work with them. But I think the best part was I swear I was told this was true. Maybe this is an apocryphal tale, but what I was told was that when it came time then to dispose of our competitors' machines, why would you pay so much money to actually ferry them back to Earth? So they got the 32 feet per second acceleration treatment, dumped them out, burned up on the way back to Earth.
As the story goes, they literally ejected your competitor's equipment to burn up in the atmosphere and shipped up some of your equipment.
That was the best part. Yeah. That's kicking out a competitor.
Yeah. I would probably put that email framed on my wall. I've been trying to keep track of my R acronyms, VR, AR, and then now XR. Can you explain a little bit, briefly, kind of how those all play together and what they are?
Yeah, I mean, VR is just the virtual reality, and of course, the technology has evolved, and the headsets are still pretty big. But I'm telling you, they're on a trajectory to be really more mainstream in form factors. And then AR is the ability to really project, add augmented reality or augmented annotations, if you will, graphical annotations to your regular workspace. And those two technologies ultimately, I think, will intersect in some ways, just because you're both talking about display technology that's really close to your eye, or manipulating your eyes to give you this more immersive experience, or to give you this, these augmented capabilities on top of your, what you see in reality. We're very close in relative terms. We're probably a few years away from seeing some very groundbreaking changes to how humans interface with computers, and with how we interact in general. Even during the pandemic, Zoom and all these video conferencing platforms became very prevalent. We use them; they're very helpful, but they're still person looking at display with a computer. And I think the whole notion of a metaverse and really a more immersive platform for how people interact with compute, it's coming. It's just inevitable. And how you interact with that, the VR, AR, or XR, extended reality, is really just advancements and technology in terms of that human computer interface, and how you can create a more immersive interface with the compute and the platform that you're working with.
And I think you mentioned accurately, there's a tie-in then to edge compute as well, right? You need to maintain extremely high frame rates and very low latencies. And so, yeah, that's a natural. I think all of us believe that when augmented reality becomes mainstream. This is going to be really, really revolutionary. And it can hit other ways too. It can be through the headset. We've also been experimenting with panes of glass. If I'm in a control room, or say I'm the harbor master, or flight tower, can I look out and when I see planes or boats, could they be annotated? Can I tap on that and say, "Great, tell me everything you know about that"? Yeah, and it's a pretty exciting set of use cases as well. That surprised me a little bit. At first you think, well, it's for playing games, right? Well, it does. You can do some real kick butt games with them, but training, in factories, military training, there are just all kinds of. Eventually, I'd like to get to where an architect could go through a construction site and look around and see how it's supposed to be, X-ray vision, right? See through walls in an existing facility. It just, the mind sort of boggles with all of the things that you can do with this when it gets mature. So we're working as hard as we can to accelerate it.
And Bruce hit on a very important point. When we talk about use cases and workflows, VR is a perfect example of one that requires a tremendous amount of computational power. And the more immersive you get, you start thinking about having, instead of just 2D display data, now you've got massive, very high resolution, high refresh rate, 3D data. I mean, you're talking about big data and trying to crunch that real time to do real time, interactions. That's a perfect example of the drivers for compute and why a lot of our technologies and assets are going to help us play in these spaces.
I think the last thing I would say about it is I think as an engineer, I've had a certain amount of frustration. I've worked in human interface for a long time. I mentioned I worked on touch and pen, and I don't think it's ever really fulfilled its promise. But we're basically still using. I've still got a keyboard and mouse here. I've had them here for decades. I've got a monitor, a keyboard, and a mouse, and that's how I talk to my computer. We've got to be able to do better than that, right? And so I think there's a belief and a hope that these immersive technologies could eventually lead to a more effective, more efficient, more natural way to do the human interface for humans to interact with computers.
Yeah, and that's gonna affect how we collaborate. It's gonna affect this whole idea of hybrid, which is very real. I mean, the pandemic, one side of it is, hey, the good news is we adapted. The bad news is we adapted. You go 1.5, 2 years of kind of doing things differently, and things change. And I think the world has changed forever. And I think this notion of hybrid is less about working from home, although that's part of it, but it's really more about working with others and creating with others that are not in the same location. So whether you're in the office or at home or wherever, at any given moment, you're going to be working with people that are not where you are. And so the ability to do that, and this was true, by the way, and there were lots of work before the pandemic to really enable people in different locations or, different companies or whatever to collaborate more. So there was a lot of work going on there. The pandemic simply just, poured gas on it and ignited it in terms of acceleration of this whole notion of hybrid, which is I'm going to be working and collaborating with people that are not where I am at. And so there's a tremendous amount of innovation that's going to come in terms of coming up with new ways of doing things that help our customers be productive, collaborate, connect, and create from anywhere is kind of a really, really big deal.
Jim, Bruce, thank you so much for being here today.
You bet. Thanks for having us.
Thanks for joining me today in the lobby. If you like this podcast, please subscribe in your favorite podcast engine and check it out on allaboutscircuits.com. If you already do that, one way you can help this podcast is to share it with someone else you think will enjoy it. I'm your host, Daniel Bogdanoff. Next time on the Moore's Lobby podcast, we'll hear from co-founder and CTO of Embark, an autonomous semi-truck company.